Hi everyone. So what we're going to work on today is solving rational equations and rational inequalities. So first of all, a rational equation has at least one rational expression. Okay, so when you look at this, we've done a bunch of work already with adding and subtracting um, rational expressions that have common denominators or do not have common denominators, and then we have to get them. So we're going to kind of use those skills in solving rational equations. So what I want you to do is I want you to look at these denominators, and I want you to think about what would be the least common denominator of these three denominators. So you're going to look at 4, 8, and 2. What's the smallest value that they all divide into evenly? Well, I think we can all agree that it's 8. And then we have to look at our variables and see what would, be the biggest exponent of our variables, because that would be the least, common. So we have f, f, and then we don't have an f here. So f would be um, our variable right there. So our least common denominator would be 8f, okay? We might also think like, what does this have that this needs and all that kind of stuff that we talked about in class. So here's where we go a little bit different. When we're solving rational equations, we don't want to get common denominators. We want to figure out what the common denominator would be so that we can get rid of the denominators. Because what we're actually going to do right now is multiply each and every value, each and every term, by the common denominator, if we were to get the common denominator, right? Watch what's going to happen here. F over F cancels out. 8 times 1 is 8, divided by 4 is 2. We got rid of our denominator right there. That was the goal. In the second fraction, 8f and 8f completely cancel out, so just we're left with 5 equals, don't forget your equal sign, 8f over 2. Well, the 8 and the 2 can be reduced, and we wind up with 4f. And then what we do is we go ahead and we solve. So we get 7 equals 4f, divide, divide, and we find that f equals 7 over 4 as a decimal, which, I'm not a huge fan of decimals. I'd rather the fraction. You could keep it as 1.75, or of course 1 and 3/4. All of those are acceptable answers. So we get rid of our denominator so that we can solve our equations. There's one other thing we have to do here. We know that denominators cannot equal 0. So what we're going to do is we're going to look at our denominators, and we're basically going to say 8f cannot equal 0 and solve for the variable. So divide by 8, divide by 8, f cannot equal 0. It puts a little restriction on our variable, okay? And now if we were going to check this, we would just substitute, and I'm probably going to use this value, we would substitute it into our original equation. I'm going to erase that so we can see. And so we would have 1 over 4 times 7 over 4 plus 5 over 8 times 7 over 4 equals 1/2. And let's see what happens here. Well, 4 over 4, they cancel out. 8 over 4, they reduce. So we have 1 over 7 plus 5 over 14 equals 1/2. We're going to get common denominators here, so by 2 over 2, and we get 2 over 14 plus 5 over 14 equals 1/2. And look what we get. 7 over 14 is 1/2, and that would reduce, so perfect, it worked. Let's go ahead and let's check the next one. So let that sink in. When you're ready, we'll move on. Okay, so this one looks a little different, and what I want you to think about is, of course, factor, factor, factor. So we look at this denominator and we know we would factor this to be x plus 3 times x minus 3. So hopefully you'd know, okay, if I wanted to get common denominators, I would multiply this fraction by x plus 3 over x plus 3, this one by x minus 3 over x minus 3, and this one, of course, we would already have the common denominator because this is actually the common denominator. So I'm going to bundle this up, and I'm going to multiply each and every term by x plus 3 times x minus 3. Okay, x plus 3 times x minus 3, and the last term by x plus 3 times x minus 3. So what you'll notice here is that the x minus 3's cancel out. So we're left with x times x plus 3. I'm going to distribute that right now because it gives me x squared plus 3x. Then we look at the second fraction. Well, x plus 3 and x plus 3 cancel out. That's good news. And again, we will distribute this. So we get x squared minus 3x equals, hey, all of this cancels with all of this, okay? So we just wind up with a 2 over here. Let's see what we have. 2x squared. Well, look, these happen to cancel each other out. 2x squared equals 2. I'm going to move everything to the same side of the equation and solve this. Now let's remember how we solve. First thing we check, is there a GCF? Yep, we can take out that 2. Now we're going to see, can we factor this? You bet we can. It's going to be x plus 1 times x minus 1. Okay, we would set each of those equal to 0. Of course, 2 cannot equal 0. When we solve this, we get that x equals negative 1 and x equals positive 1. We have 2 answers. So let's think about this. We still have to look at our denominators, and you can look at this one here too. And we have to say that, we have to figure out what values would make the denominators equal 0 because x cannot be those numbers. So we would take x minus 3, we take our factors basically, and say that cannot equal 0. So we know that x cannot be 3. And then, of course, we take our other one, which is x plus 3 equals 0. Oh, I'm sorry, cannot equal 0. And so x cannot equal negative 3. So that's really important because if either of these answers had come up to be 3 or negative 3, they would be extraneous. We would just have to get rid of them. And then you check your answer. So we're going to check, I'll check negative 1 first. So negative 1 over negative 1 minus 3 is negative 4 plus negative 1 over negative 1 plus 3 is 2 equals 2 over negative 1 squared is 1 minus 9 is negative 8. I don't know, you might do this differently than me. I would immediately reduce this to be negative 1/4. I know that a negative over a negative is a positive, and I know I need a common denominator over here, so I would multiply by 2 over 2. It's going to give me negative 2 over 4 plus 1 over 4. That gives me negative 1/4 equals negative 1/4. It worked. So we know right now this is a solution. The negative 1 is a solution. We're going to do the same thing to check positive 1. So again, go back to your original equation. We have 1 over 1 minus 3 is negative 2 plus 1 over 1 plus 3 is 4 equals, winds up being almost the same thing here, doesn't it? So it really turns out to be about the same. Oops, I'm sorry, that should have been a 2 up here. Sorry about that. Things work out the same because it's essentially the same problem. Okay, negative 1/2 plus 1/4. So we're going to get the same answer. Negative 1/4 equals negative 1/4. So that one worked as well. So both answers work. Just keep in mind they won't always both work. Sometimes one works and the other doesn't, or we have an extraneous solution. All kinds of different things can happen. Okay, here we go again. Let's see what happens. So let's look for factoring. We know that we can factor this denominator to be x plus 1, x minus 1. We can try to factor this, but it doesn't factor. So what we know is that this is our least common denominator, right? So in other words, this has x plus 1. This would need the x minus 1. This is x over 1, so that needs everything. So we're going to multiply each and every term by x plus 1, x minus 1. Okay, so this one, x plus 1, x minus 1. And this one, x plus 1, x minus 1. This is going to be an interesting one here. So looking at this, I have x times this whole value. Well, remember, I know that this value actually started out as x squared minus 1, didn't it? So I'm going to multiply x with this value, okay, which is just the FOILed version of this. We get x cubed minus x. Oh, can't see what that sign is, so it's an addition. So plus, and now all of this cancels all of this, and we get x squared minus 5 equals, over here, the x plus 1's cancel, and we're going to have some distribution to do here because we have to distribute the x, and then we have to distribute the negative 1. So x by x squared is x cubed, x by x is x squared, x by 2 is 2x. Then we distribute our negative 1. We get negative x squared minus x minus 2. Let's clean this all up. It's a mess. First of all, I see x cubed on the right and x cubed on the left. I know they're going to cancel. Might as well do it now rather than carry them around for a while. On the left side, we can put those in descending order. And on the right side, we can see that certain things cancel out. Certain things can be combined, right? So we have x minus 2. As usual, when we have a quadratic and we're solving, we're going to move everything to one side. Okay, so here we go. We have x squared minus 2x minus 3 equals 0. We will factor that. We get negative 3 and positive 1. So our solutions are 3 and negative 1. Okay, so that's good news. Let's take a look at our denominators. And let's write the constraints for our denominators. So we know that x plus 1 cannot equal 0. So x cannot be negative 1. And we know that x minus 1 cannot equal 0. So x cannot be positive 1. Well, wait a second. We have a little conflict here. It says that x cannot be negative 1, and when we solved, we got x to be negative 1. Can't be. You're going to cross that out because that is an extraneous solution. If we were to put negative 1 down here, we would have an undefined fraction. It doesn't mean you solved it wrong. It just means it's an extraneous solution. It would make the whole problem not work. But we do still have to test the 3. To be honest, it could wind up that the 3 could be extraneous also. We're going to test it. So we have 3 plus 3 squared is 9 minus 5 is 4 over 3 squared is 9 minus 1 is 8. That's looking like 3.5 right there, isn't it? Over here we have 3 squared is 9 plus 3 plus 2 over 3 plus 1 is 4. I think we can all agree that this is 3.5. Okay, let's see what happens over here. 9 plus 3 is 12, plus 2 is 14. 14 over 4, well, let's see, divide by 2, divide by 2. That's 7 over 2. And 2 goes into 7 3 times with 1 left over. So we get 3.5 equals 3.5. So it works. So x can equal 3. Okay. So I wrote here what happened, and that's just that I was going for that the -1 was an extraneous solution. It wound up in being one of the values that we could not have. So here's what I want you to do. I just want you to solve this problem right here. See what you get for an answer. And we'll pick up here in class next week, next class. Have a great day, everybody. Bye.